Okay. So let's take a look at these. On part A, it looks like we've got. Let's go. So Emma. So Victor, you got all points on that one. Emma, you didn't get any. Did you make a mistake along somewhere along the way here? Which step of this tripped you up?
Yeah, I have never really been super comfortable with implicit differentiation, and so I didn't really know where to start. But now looking at your like response, it makes a lot of sense now.
Okay. Yeah, so when we're taking the derivative of implicit curves, we just have to be careful to treat both any expression in terms of x, well, it's a function of x, and any expression in terms of y as a function of y. So one way to think about this is x times f of x plus f of x squared equals x. And then when you differentiate, we've got to use the product rule for x times f of x, and then you have to use the chain rule for f of x squared. And then, of course, the derivative of x is just going to be 1. So that's what I've done here. So here's the product rule for that first term, and then here's the chain rule for the second term. And then it's just a matter of factoring and getting down here to the algebraic answer. 2 points here for the implicit differentiation and 1 point for the algebra. So in other words, if you got this line totally correct, you could still get 2 out of the 3 points, even if you made an algebra error or couldn't figure out how to get down to the end there. They essentially gave, from part A, they gave you a starting place for point B. They wanted you to find the second derivative of y with respect to x. But, well, that's just the derivative of the answer from A. So they've given you a starting point. So it looks like we got a 3 and a 2 on this one. So Emma, I think you got full credit on this one, and then Victor, you got 2 out of 3 points. Victor, you want to tell me what gave you? Where did you mess up on part B?
It's just I have messing handwriting, so I sometimes do a mistake where my minus looks like a plus sign or like x. So like I added a variable and I should subtract it. So just my answer was wrong. So that was very close.
Okay, I do want so because the first derivative is quotient, we're using the quotient rule here, keeping in mind that every time we take a derivative of an expression in terms of y, we got to use the chain rule, right, and put those derivatives of y with respect to x in the right place. This answer, this first line right here, earns the first point, but not the second and third point, because you've correctly applied the quotient rule to dy over dx. This line, if you stop right here, earns all 3 points without doing any additional algebra, because this answer is algebraically equivalent to any other correct answer, so it gets full credit. Now, I've continued simplifying here and getting it down to this form. However, that's not required. If you attempt to do this simplification and you do it incorrectly, you're going to lose the answer point. So for both sake of time and to lower your risk of losing a point, just stop right here. Okay, that's a good rule of thumb. As soon as you get down to like the place where it's just algebra or just calculation, you can stop. You don't have to spend more time working on that.
Okay,
Okay,
wait. So I just replace it dx and then that's it. I'm done.
yeah, that's done. They're not in this case, they don't really care about you doing all that algebra, and if you do it wrong, you're going to lose a point. Okay, so for part C, you both scored 2 out of 3 points. Emma, which point did you lose in part C?
I think, oh yeah, I just did not get the correct numbers at the end. I think it was just an algebraic like miscalculation.
Okay, Victor, what about you?
I think I'm in the same boat too.
Okay, so these questions about vertical tangency can be kind of tricky. But when we have an implicit curve, what we've got to remember is that this is the expression for slope. And in order to have a vertical tangent, that slope's got to either go to positive or negative infinity. The only way a fraction can become infinite is if the numerator takes on a value of 0 and the denominator takes on a value that's not 0. The rubric does not refer to this second calculation anywhere because it's not required to actually solve the problem. But it's good to remember that the reason we're setting the numerator equal to 0 is because that's when excuse me, I'm getting my numerator and denominator backwards. We're setting the denominator equal to 0 and the numerator must be non-zero so that you get that constant over 0 form to create an infinite value. So that x plus 2y has got to be 0. I solved for x here in anticipation of what I had to do down here in the final step. X equals negative 2y is not enough information to find points on the curve, but I also know that points on the curve satisfy the original implicit relation. So since x equals negative 2y is a requirement, I'm going to replace the x here in the x and the xy with a negative 2y. So it'd be negative 2y times y, or negative 2y squared. Then over on the right-hand side, the x gets replaced with negative 2y. Victor, I see a question on your face.
I'm just checking the algebra.
Okay. When you get to this point right here, where it's only in terms of y, your algebra brain should immediately notice that this is a quadratic equation in terms of y. And there's two ways to solve it. Both ways require that you move everything except 0 over to one side. And then the two ways of solving it are either factoring, if that's easy, or using the quadratic formula if it's not. In this case, negative 2y plus y squared, okay, that's just negative 1y squared. And we add negative 2y to both sides. And so we get a positive 2y on the left and 0 on the right. This is now easily factorable. I can just now factor out negative y, which leaves y minus 2. And so y equals 0 and y equals 2 are the two solutions to that quadratic equation.
Okay, I saw myself. I treated that where you started in negative 2y squared. I kind of treated it as if that was y to the third power. So I was doing it as a, like, instead of combining like terms, I treated it as like a different term.
Okay. Yeah. Anytime you have the opportunity to combine additive like terms, you should do so. The question asks for points on the curve, where the tangent to vertical points have two coordinates, both x and y. So we've got the y coordinates. We've got to now go calculate the x coordinates and present our answers in xy pairs. So when y is 0, x is negative 2 times 0, so it's also 0. And then when y is positive 2, the x coordinate would be negative 2 times positive 2, or negative 4. Let's see. Even if you mess up on the algebra down here, you can still earn the first and the second point. So if all you do is get to some version of this step, you've got 2 out of 3 points. And that's usually going to be the case. If you've done everything except the algebra to get the final answer, then you're usually going to only lose 1 point. So for the sake of time, you can say, okay, I'm going to stop here and go work on another problem that I know I can get, that I know I've got time to do and I have to get full credit on. Okay, are we, Emma, did you have any other questions?
Nope.
Okie doke. So let's move on. So I now want y'all to look at free response, Unit 5, free response question number 1. The question looks like this. Because this one is graphical input, this will go a lot faster. And if you did your pre-work, you should already have it done. But open the rubric and open the scoring form and give me your responses just like we did last time. Go, Emma, you did well on this one.
Yeah, this one makes a lot of sense to me.
Victor, let's go ahead and wrap this one and get up and get your solutions into the form, please.
Mr. Nichols, I have a question.
Sure.
For the AP exam this year, are we gonna be able to have, is it gonna be like open note how it was last year?
No.
Okay,
This one's paper and pencil.
okay,
So y'all have the advantage of being able to go back and forth to multiple choice questions, you know, like work ahead and come back to a more difficult question, but you can't use your notes. Folks that are taking it online, I think they're going to be able to use their notes because it can't be prevented, but you can't go back to questions. You either have to answer it or skip it and move on, and you can't go back.
okay, and so Grady's taking them in person then?
Yes, yeah, the second administration window is the face-to-face administration. Victor, I'm not sure what North Atlanta is doing. Mr. Ehrman has not, I haven't gotten a clear indication from him one way or the other. All right, so Victor, I got your response. Let me take a look here. All right, so looks like oh, okay. So Victor, it looks like you recorded a total score of 9, but you recorded a score of 1 on. Oh, excuse me, that's not the right question. No, never mind. You got full credit. Okay. So I'm just gonna make a couple of brief comments here since y'all both got full credit on this one. You've got to be really careful about writing complete justifications on problems like this and not leaving out important details. For instance, in part A, the second point is for classifying the critical points as mins, maxes, and neither with a reason. So for x equals -4, you must explicitly state that f prime doesn't change sign. If you say it changes sign or doesn't change sign, or the graph doesn't change sign, you will not get the point. You have to be very explicit. F prime does not change sign. Same thing is true here for x equals 0. F prime changes sign, and then you have to dictate this in the right order, from positive to negative. I use shorthand there. You write out the words that matter. They did not include, they told you to look at the open interval -6, 6, so any reference to the endpoints is just going to get ignored. And it's also just wasted work on your time because they told you not to worry about them. So in all the parts, there's that same thing about clear communication. In part B, it's since f prime of x is greater than 0. You've got to use correct notation there. You can't say because the slope is greater than 0. No, or because the graph. No, f prime has got this one is greater than 0. In part C, it's about point of inflection. This thing about, so here, this is actually a tricky one to get full credit on. You may have given yourself credit for this one, but not quite had a full justification. You've got to talk about why the second derivative changes sign, not just equals 0. Point of inflections require that the second derivative changes sign, but you can't jump from f double prime to a conclusion that it changes sign. You have to go through this linkage about the slope of f prime. So f double prime is the rate of change or the slope of f prime. And the reason you have to do this is because the graph of f prime is the information you were given. You have to reason and give evidence from the information that they've given, not just based on general true facts. Okay, so you got to cite that reason in the information that was given. Yeah, a lot of students would lose the point in part B because they didn't have a complete justification here. Same kind of justification here is required in part D to find that interval f is concave up. you've got to say that the reason is because f double prime, which is the slope of f prime, is positive. You can't just jump and say f double prime is positive. You've got to link it to the graph that they gave you, which is the graph of f prime. So based on that discussion, does that adjust your score any? Did you lose a point looking at some of those, lose a point or two looking at those details?
Yeah, I think I lost a point on part C.
Okay. Victor, what about you?
I just want to check. I put f double prime is equal to d dx of f prime, and I put changes like from positive to negative at x equals -4. That's what I put. Does that count?
So it might. That's the best answer I can give you. Okay. I know that this will receive full credit. Okay. Because you're just saying that the derivative of f prime, or excuse me, the derivative of f prime changes sign. Well, you don't have any direct given information about the derivative of f prime. You have to read that, you have to interpret the graph. So any interpretation that you do, you got to explain how you did that interpretation. So I think you probably would have lost a point there in part C as well. I don't think they wouldn't double ding you. So if you made the same mistake in part D, they would not, well, actually, no justification is required here. So yeah, so you could probably still get full credit on D even with a little difficulty in justification. Okay, anything else about that one we want to talk about? Let's move on to, let's see, we're right on schedule. So we're going to do this last free response. And let me just ask you honestly, have both of you already worked this out?
Yes.
I did.
Victor, was that a yes or no? I didn't quite understand you.
Yes.
Okay, so then let's go ahead and score it. You've got the digital copy linked in the, linked in the presentation. So open that up and go ahead and open up the form for it as well and let me know what you got. All right, let's wrap this one up and get your response into the form, please. All right, Victor, best guess. Let's go ahead and get the score submitted. Look here. You both got full credit on part B. Good job. And got 1 point on part C. We're definitely going to talk about part C. Both of you got full credit on D. Okay, so yeah, let's talk about A and C. So I want to point out here that in these types of problems, sign charts like this and like this are very useful for helping you organize your thinking, but they will not ever be sufficient for you to earn full credit on the problem. You have to take what you learn from your sign chart and interpret it in an actual conclusion citing the relevant information. So let's see here. So we set the derivative equals 0, find the critical points. Then I'm choosing test values in each of those intervals. I'm plugging those test values into f prime and checking for the sign. And then we get decreasing when f prime is less than 0, and that only happens on the interval from -0. So Victor, where'd you lose a point on part A?
I forgot to put in the interval for my answer. I just put f is decreasing since f prime of x is less than 0. I just
Okay.
forgot.
Okay, good. All right, gotcha. So in that case, you would have actually only earned the first point for that, I think. Or did you ever write anywhere on your paper that f prime of x equals 0?
I did. Like I did all that. I just in the answer I didn't put in f is decreasing interval -1
Okay.
less than 0. I just
Yeah.
didn't do that.
Both the second point and the third point require a reference to the interval -1, 0. So if you leave that out, you can't get either the second or the third point.
Oh, okay. So
Okay. So B is very similar to that, but both of y'all got full credit on that one. Finding the second derivative, finding where it's positive and negative after finding its critical point. In part C, now this is a part C this is a tricky problem. Most students do not earn full credit on questions like these on the exam because they can be a little bit, sometimes they can be quote unquote easy, but most of the time there's something that's tricky about the justification. So they wanted us to find the value, is there a value C on the closed interval 0, 2 such that f prime of C equals 14. Now, when you read that statement, hopefully your calculus brain goes, oh, that's about the mean value theorem. They're wanting me to find a point in an interval where the value of the derivative takes on a particular value, or the derivative takes on a particular value. And really so that directly should at least raise a flag for mean value theorem. Well, mean value theorem says that the only way, it says the only way you can guarantee a slope of 14 is if the average rate of change on the interval 0, 2 is 14. So we're going to calculate the average rate of change on that interval. To earn that first point, you have to clearly write out the difference quotient. If you only write 28 divided by 2 or 14, you're not going to get credit for the difference quotient. You either need to write the formula with the numbers plugged in, or some version of one of these two to get that difference quotient point. Now, the second point is tricky. We need justification that references differentiability, continuity, and the mean value theorem. So those are basically citing the mean value theorem correctly and noting that the conditions for the mean value theorem, differentiability, and continuity have been met. So I believe they told us at the beginning of the problem that f was twice differentiable. Well, which means f is differentiable, but differentiability implies continuity. So it's differentiable everywhere, and that implies that it's continuous everywhere. Those are the two conditions for the value theorem. And then you've got to make mean value theorem statement. So since those things are true, we know that f prime of c has to equal the average rate of change on that interval, which is 14. So that's got to be true for some c between 0 and 2. Questions, comments on that one? Part D is a closed interval method problem. You're finding an absolute min or an absolute max. If you recognize that x equals -1 is the location of a local maximum based upon the work that you've done above, you can leave it out of your table and save yourself some computation. So you only have to consider x equals -3, 0, and 1. Make sure you check those endpoints. And from there, it's mainly just computation, right? Do you do the computation right, and do you recognize the answer correctly? Be sure that if they ask for the minimum value, you give them that value. So if I had stopped right here and just said at x equals -3, I would have not earned the second point, because the minimum value is the value of -31, the value of f of -3. Okay. All right, great. So I think we are really close to being on schedule. Okay, so then let's shift over to multiple choice mode. So I hope you have solved your multiple choice problems, because we're going to play a little Kahoot. Now the link for the Kahoot is in the on our slide in the Google slide deck. So go ahead and follow that link, and let's see who wins. We got a little one-on-one contest here. This teacher mode. The Kahoot will time out after 10 minutes, but if you finish before 10 minutes are up, please let me know so that we can continue with our discussion.
Okay, I finished. I didn't do very well though.
Okay. So it looks like we've got at least 3 that we definitely need to talk about.
I'm done as well.
Okie dokie. So yeah, all right. So yeah, these looks like these are a little tricky for us. So let's take a second here and see how we did. All right. So the first question was number 86. Do y'all want to, because we'll just work them out. I've got my answers written out already, but I think it would be beneficial to kind of talk through these as well. Okay, so 86, excuse me, 83 was the first one. Up there. 83, there we go, there's 83. All right, so we've got f of x is continuous and always increasing on the domain AB. Which of the following about f of x is false? Okay, so always increasing means that f prime of x is greater than 0 on that interval AB. We know it's continuous and we know it's increasing, and that's all we know. So part A, f of x attains a minimum value on the interval AB. Well, it's continuous, so the extreme value theorem, it only requires continuity. The extreme value theorem guarantees that there must be a minimum, and there must be at least one minimum and at least one maximum, or there must be an absolute minimum and absolute maximum, to be clear. So choice A and choice B are those two statements. So these are guaranteed true by the extreme value theorem. Continuous functions must have an absolute maximum and must have an absolute minimum on a closed interval. Okay, let's look at part C. F of x attains both a maximum and a minimum value. Okay, actually, so let me extend my bracket. Yes, the theorem says it has both. It must have both. So that only leaves D. So D's got to be our answer. But let's read over it and make sure. Okay, f of x attains neither a maximum or a minimum value. Maybe okay, that directly contradicts the extreme value theorem, and so therefore is false, which is our answer.
Wait, I put D as my answer, but it told me I was wrong.
Yeah, I did the same thing.
Uh-oh, SpaghettiOs. Let's see. I did not build this Kahoot. I borrowed it from somebody else, so I apologize. I hope we don't have more like that. All right, but are we good? Yeah, you said y'all both got that one. Okay, so let's move on here. So we're looking at 80. Why are these in weird order? 86. Okay, so here is 86. We've got a graph of f of x shown above. Which of the following statements is true? Well, let's just first examine f of x. It's decreasing and it's concave up. So f decreasing says that f prime is negative. F concave up tells us that f double prime is positive. And notice that right here at 2, f of 2 equals 0. So all of these inequalities are about f of 2, f prime of 2, and f double prime of 2. Well, if f prime is always negative, well, that means f prime must be less than f of 2, which is 0, and then f double prime is positive, so it's got to be greater. So we need the one that has f double prime on the top, either A or C. We need the one that has f of 2 in the middle, so it's got to be the correct answer must be C. Did the Kahoot tell you got that one right? Say the answer was C. Hopefully that one was broken.
Yeah, it said C was the correct answer.
Excellent. Okay. All right. Okay. Well, let's look at the next one, which is 87. All right, we got this. Oh, I think we've seen this graph before, and it is the graph of f prime of x. So f is differentiable, and the graph of f prime is derivative of f shown above. At what x values does the graph of f have a relative maximum? Okay, well, relative maximum means that f prime changes from positive to negative. So we're looking for points on the graph where f prime changes from positive to negative. Now, f prime is the graph, and so we're simply looking for the points on the graph where the y value of f prime changes from positive to negative. All right, that occurs there, above the x-axis, then below, and nowhere else. That's the only one. There is a minimum at x equals 0. And then we're not going to consider the endpoint. So yeah, so that gives us the answer of A. Okay, then 88. Yeah, 88. Sure this focus is no bitty. All right, so this one's a little tougher. If f of x equals natural log of x cubed plus 5x squared plus 5, then for what value of x does the graph of f of x have a relative minimum? Okay, we have a continuous function, and so we know we're going to find relative mins and maxes either using the first derivative test or the second derivative test. Let's not choose between those just yet, but we know the first step in both of those is to find the places where f prime is 0 or f prime is undefined. Okay, so we need to know f prime. That's like step 0. I want you to notice that our f of x here that we need to take a derivative of has the form that it's the natural log of some function that I'm going to call g of x. Well, we know what the derivative of the natural log of x is. It's just 1 over x. Combine that with the chain rule, and the natural log of g of x, no matter what g of x is always going to look like, it's always going to be a fraction, g prime of x over g of x. That's a little, just for efficiency, just, you can do it the long way, that's fine, but this is just a little quicker. So in our case, f prime of x, it's the natural log of this cubic, so we know the cubic function is going to be in the denominator, and then the derivative of the cubic function has to be in the numerator. And we want to know, where does f prime equal 0 or does not exist? Those will be our critical values. Well, in order for the derivative to be 0, the only way this fraction can be 0 is if its numerator is 0. All right, fraction a over b equals 0, a has to be 0. Well, we're going to factor an x out there, because again, it's algebra brain. Hey, it's quadratic. I either need to factor or to use the quadratic formula. I don't like the quadratic formula, so I'm going to try to factor first. So you can't factor out the GCF, and you get x equals 0 and x equals negative 10/3. Well, this is where multiple choice strategy comes in. X equals negative 10/3 is not in the list of answers, and I'm really confident that x equals 0 is a critical point. So what I would do as a test taker is I would just go ahead and choose C and keep going. All right, save some time here, because we know x equals 0 is a critical point. Now, if there's a choice here that said none, okay, I need to do some more work. But if there isn't a none of the above, the answer's got to be 0, because that's the only critical point that's only one of the 2 critical points that's in our list. If you want to prove that it is a that it is actually a minimum, you would have to do you would either do a number line test with f prime, or so you could use the first derivative test and do a sign chart for f prime, or you could use the second derivative test. That requires that you calculate f double prime, which requires quotient rule. So neither of these things is particularly fast. So I would say as a test taker, I would say, oh, okay, I'm going to hedge my bets here. I'm just going to go with x equals 0 and keep on rolling. Okay, so then the next one was, let's see, 87, 88? No, you just did 88. So the next one is 90, 98. I picked these problems to try to be representative of the larger set of problems, but there's no way to hit everything in 5 or 6 problems. So go back and solve the other problems, and I'm going to post the solutions on Google Classroom. So for number 98, get the sum of the height and the radius of a right circular cylindrical cylinder is 12 inches. What is the maximum volume of the cylinder? The volume of the cylinder is B equals pi r squared h. As soon as they say this statement, maximum, what is the maximum volume of the cylinder? I immediately know this is an optimization problem. Furthermore, it's an optimization problem on a closed interval. Now, they don't give us the closed interval, but we know that because the sum of the height and the radius has to be 12, that the radius has got to be between 0 and 12, right? Because if the radius is 0, then the height would be the 12, and if the height were 0, then the radius would be the 12. And you can have any range of values in between. So we've got an optimization problem on a closed interval. So we're going to just be able to find critical points and test those along with endpoints to find the maximum. Well, the other problem that we have is that the volume formula is in terms of R and H. We don't want to do this using implicit differentiation if we can avoid it, and we can avoid it because we've got this statement up here that the sum of the height and the radius is 12. So we know that R plus H is 12, so H is 12 minus R. You can also do R equals 12 minus H, but there's actually an advantage to doing it this way. If I solve for H and replace the H here, that means I don't have to, if I replace the R, I'd have to square it, and the algebra would be harder. So I'm going to replace that H with 12 minus R, and we're going to use that as our volume formula. We've got to take the derivative of this with respect to R, but I don't want to use the product rule, so let me distribute. I'll leave the constant outside because we know how to deal with that multiplication. It's a little bit easier to differentiate polynomials when they're multiplied out. We don't have to use the product rule. So dv over dr, pi is a constant multiple, comes along for the ride. Derivative of 12r squared would be 24r. We're taking the derivative with respect to r, so we don't multiply by dr over dh or dr over anything, because everything here is in terms of r. Then minus the derivative of r cubed, so that's 3r squared. And that's got to be equal to 0. Well, again, quadratic, we either got to factor it, quadratic equals 0, we either got to factor it or use the quadratic formula. I would rather factor this thing. I'm going to factor a 3 out, and I'm going to factor an r out. So 3 pi r, let's see, 3 goes into 24 8 times, and that would just leave an r. So we have that r is 0 or r is 8. Now, we can rule out r equals 0 right now, because if the radius were 0, the volume would be 0. And that's obviously not the maximum volume, right? There is some value. So at this point, the only things we have left to do are to consider r equals 0 and the other endpoint. So we've got this interval 0, 12. Well, if r is 12, then the height would be 0. And again, the volume would be 0. So that cannot be our maximum volume either. So our maximum volume has to be at r equals 8 without us really even checking much anything else. But we've got to calculate the volume of 8. What I'm going to do So I'm going to use the formula that we create. Actually, you know what? I'm going to use the factored formula because that's going to be easier to calculate. I'm going to plug in 8. So let's see, that'd be 8 squared, so 64 pi, and then 12 minus 8 is 4. So our answer is whatever is 64 times 4 times pi, and I believe that is choice D, 256 pi. Okay, so this is one of those problems. It does take a bit more thinking and calculation to do it. This is not a quick one, which is why you need to do the quick ones quickly, so you can save time for problems like this that take just a little bit more thinking and a little bit more computation. All right, I got 4 minutes. We're gonna make it. Number 99. Okay, so implicit differentiation. I think we. All right, so let's go over this one bit by bit. We're going to take the derivative of this implicit curve with respect to x. So xy is going to require what differentiation rule?
Product rule.
Yep. We're going to need the product rule there. What are we going to need to use in the, which rule do we need to use to differentiate y squared?
That's the power rule with implicit differentiation.
So yes, so it's the power rule, but we need, so when you say with implicit differentiation, what that means is we've got to make sure we think about the chain, right? Because y is a function of x, so and it's a function squared, so we got to use the chain rule. All right, so product rule on x, y, let's see, that would be x times the derivative of y plus y times the derivative of x, which is 1. So that's our product rule, plus the derivative of y squared, okay, power rule, 2y to the first times chain rule, dy over dx. Over on the right-hand side, it's just a linear function of x, so we know the derivative is the slope of 5. And then we want to know where it has a vertical tangent. All right, so we need to solve this thing for dy over dx. The first thing I'm going to do is look for terms that do not have a dy over dx in them like this one, and I'm going to move that term to the right using algebra. So the right-hand side is going to be 5 minus y. Then I'm going to recognize the terms that do have dy over dx in them, and I'm going to factor out dy over dx out of those terms. So here this would leave an x, here it would leave plus 2y. Now, so that means dy over dx is 5 minus y over x plus 2y by dividing. Well, if we want to know where it has a vertical tangent, as we said before, that has to be a place where the denominator is 0 and the numerator is non-zero. This is so at this point, I think what I would do, rather than doing the algebra, we've got a list here. So let's just, these are x values. So let's just plug in x values and see what we get now in the expression in terms of x and y. Well, so I see how do I do that? I'm trying to think of the most efficient way to do this. Yeah, I was thinking maybe we could work backwards from the multiple choices, but there's not a quick way to do that. We'd have to calculate the y's, which means we'd have to substitute the x value in here and solve for y, which again is going to be a little time consuming. So we'll have to do it this way. You know, x plus 2y has to be 0. So that means y is negative x divided by 2. Oh, now I can test the y value. Now I can find the y values. If x is 0, y would be 0, which means x plus 2y would be 0. So a is a possibility. So we'll put a maybe there. We can eliminate all the other ones, then a is the answer. When x is 1, y would be negative 1/2. Well, that would be 1 plus 2 times negative 1/2. Well, those are all going to get 0. No, it's not. No, yeah. So I'm sorry, folks, I'm tripping over my own words here. So when x is 1, y would be negative 1 over 1/2. And then we look at the expression x plus 2y, and that would be 1 plus 2 times negative 1/2. Okay, that equals 0, right? 2 times negative 1/2 is negative 1, so that equals 0. So that means that's a maybe. We weren't able to exclude. Did I do that right? Yeah, the problem is that one of these does not actually, these 2 points don't even lie on the curve. All right. Yeah, this is for a multiple choice question. This one's kind of tricky because I'm trying to think of strategic ways. So far, none of the math that we've done here is wrong, but in terms of strategy, we haven't found an efficient way to solve the problem. There usually is, but sometimes there's just not. So what we're going to have to do is we're going to just kind of have to muscle through this thing. Let's use the fact that y has to be negative x over 2, and also use the fact that we know points on the curve must satisfy the implicit relation. So now I can replace all the y's in this expression with negative x over 2. So y times negative x over 2 would be negative 1/2 x squared. Y squared is going to be plus 1/4 x squared. 5 times x is going to be negative 5/2 x. And then, of course, that's just minus 11. We got some like terms here. We can combine negative 1/2 x squared plus 1/4 x squared. It's going to be negative 1/4 x squared. And then I'm going to add 5/2 x to both sides and add 11 to both sides so that we get it as a quadratic 0. This is nasty, and I don't want to try to factor this or use the quadratic formula with fractions. So what I'm going to do is multiply through by the least common denominator. So of 4 and 2, which is 4. So I'm going to multiply through by 4. Actually, I'm going to multiply through by negative 4 because that's going to kill that negative leading coefficient. So we get x squared minus, let's see, well, 4 times 5 would be 20 divided by 2 is 10. And then negative 4 times 11, negative 44. So that gave us that got rid of all the fractions. And so now we can factor this thing as x plus 22 times x minus 2. 22 times negative 2 is negative 44. 22 minus oh, I did something wrong. That's 20x. Okay, regardless, that is 10, and so the factorization that I have here is not correct. Let's see, 4 times 11. Well, I made a mistake in my notes. That factorization is not correct. But if we try to do it using the quadratic formula, b squared minus 4ac is, so I'm not doing the full quadratic formula. That'd be 10 squared, which is 100, minus 4 times a, which is 1, times c, which is negative 44. Well, that's 100. Negative times a negative is going to be positive, plus 4 times 44. I only care that that's positive. Because it's positive, that means this quadratic equation has 2 solutions. So that means we've got 2 vertical tangents. All right. I don't see a more efficient way of doing that one. That one is tricky, time consuming. So let me go back for a second. I kind of want to stray here trying to test points. I made a factoring error down there, but let me go back and see if the general method of solution here is agreeable. Get implicit differentiation and solve for dy over dx, because we want to know where the denominator of dy over dx is 0 so that we can get a vertical tangent. Well, so we set that denominator equals 0. That does not provide any unique solutions. So we've got to combine that with the equation of the curve, because points on the curve have to satisfy that. And then once we do that substitution, algebra, we come up with this quadratic equation in terms of x, and then determine that the discriminant is positive, so it's got to have 2 solutions. Go ahead, Victor.
Yeah. At the 5x minus 11, why did you get -5 over 2x? Like, there's no y, so why does that change? Is that your mistake there?
That's my mistake.
Yeah.
That should be, yeah, so that's my mistake. Yep, that's my mistake. Okay, carry that through, and we actually get something here that factors. You get, so if you correct that, that would just be 5, which means this would be -20, which means it factors as I've got it written down on my paper. So you don't have to worry about discriminants and things. You've got two real zeros here, -22 and +2. So you've got 2 vertical tangents. Okay, so a little sloppy on the first go, but I think we got it on the second one. Emma, did you have anything you wanted to ask about that one?
No, I'm glad we went through it that second time because I was pretty lost. But now that we fixed the mistake there, it makes sense.
So I always claim that y'all watching me struggle and make mistakes is valuable for the learning process, because this is how you're going to be working these problems on the test and being able to recover and go, oh, there's my mistake, or finding that more efficient method. That's going to be really valuable to you. In this case, there just was not an efficient method. You had to just turn the crank and grind it out. All right, so good work, folks. I'm going to post the multiple choice answers. I'll attach those to Google Classroom, and so that you can work out the rest of the multiple choice and check those for yourself. And then I will post next week's assignment on Google Classroom. I'll try to do that tomorrow or Thursday at the latest. All right, I hope y'all found this helpful. I'll see y'all next week.
Thank you. Have a good day.
You too. Bye, everybody.